Welcome to Lesson 1.2, Transformation of Functions Review. To start, we're going to talk a little bit about functions and relations. Remember that a function is a special type of relation. It's a set of ordered pairs, and where every x value, there's only one value of y. So for example, if you remember back in previous courses, you would do something called vertical line test. So for example, if I had a circle, and let's say this x value here was 2, this particular x value of 2 would have two different y values, one here and one here. And if you remember the vertical line test, you would take a vertical line just to double check and kind of sweep it across your relation, and if your line touched in more than one spot, then you would know it's not a function. We start off with our standard XY notation. This is what is probably most familiar to most of you. You would sub in an x value, calculate, and then determine what your y value is. Function notation is basically the same thing. It's just a different notation. You still sub in your x value and work it out and spit out whatever your f of x value is. So for example, we have f of x here equals x squared plus 2x minus 8. Remember that f of x is read as f of x or f at x. So the notation f at 5 means you're going to take every x value in your equation and you're going to substitute the value of 5. So we will do that now. So f at 5 equals 5 squared plus 2 times 5 minus 8. And then don't forget your bedmass rules. So we raise the 5 to the exponent 2, and then 2 times 5, take away 8, and then our final answer, f at 5 equals 27. So this tells us that when x equals 5, we get a value on our function 27. So this can be written as an ordered pair, 5, 27. Now, I've seen this a lot of times, and I feel like some students feel like they need to go a little bit further, and they think that this is multiplication, because as soon as they see the brackets, they automatically think multiplication. So, I see a lot of this happening, and then they're trying to isolate for f, and then they give this to me on the test. Don't do that. That is not correct. So basically we want to stop right here. This is our final answer. Do not go any further. Do not divide by 5. So on this page here we see our Hall of Fame graphs. We'll start off with our quadratic function. It is our parabolic in shape. Remember, we get to these points. You should remember the base points. Remember your vertex is at 0, 0. And then remember your step pattern. Over 1, up 1. Over 2, up 4. And then over 3, up 9. And because your parabola is symmetrical, you get the same points on either side. Then we move over to our cubic function. Again, try to remember your base points. So 0, 0. 1, 1, 2, 8, and if we could, 3, 27. And whenever you cube a negative number, so for example negative 1, you're going to get a negative answer. So negative 1, negative 1, negative 2, negative 8 would be your next point, and so on and so forth. Scrolling down, we have our exponential equations. Remember that every exponential equation does go through the point 0, 1, as long as there's no a value in front of your equation. And to get the points that fall on your function, you just sub in for x. So 2 to the power of 1 will give you 2, 2 to the power of 2 is 4, and so on and so forth. Remember that when you have an exponent that is a negative number, so for example 2 to the power of negative 1, you're going to get a half, and then a quarter, and so on. Remember that you're never ever going to touch 0. So what happens with our exponential functions is we have created an asymptote. Next we have our reciprocal function. One over x. Remember that we can never divide by 0. So the value at x equals 0 does create an asymptote. So that's why our function approaches the y-axis but will never touch it. You also get an asymptote for your x-axis, because as your x value gets bigger and bigger and bigger, we're going to get a fraction with a denominator that's getting bigger and bigger and bigger, which gets closer and closer to 0 but will never equal 0. Next we have our absolute value function. Basically anything that you sub inside of these straight brackets ends up being a positive number. So if I sub in x equals 4, I'm going to get a y value of 4. If I sub in an x value of -5, well, if I sub in -5, it's just going to change to positive and become a positive 5. And that's why we get the straight line in the V pattern. And last we have our square root function. The best way to graph this, I find, is you want to pick values that are easily square rootable. So start with 0. If x equals 0, the square root of that would be 0. Next would be 1. Square root that, and you get a y value of 1. Square root 4, and you get 2. Square root 9, and you get 3. I'm sure you've seen this in previous math courses, but this is in general, the way that we graph functions. So every value here has a specific job to do. So if we take a look, the very first number that we see is called our a value. It's basically your vertical stretch. What a does is you multiply all of your y values by your a value, and that will give you your vertical stretch or compression. Remember that if a is a number between 0 and 1, your graph gets vertically compressed. If your a is bigger than 1, then you get a vertical stretch. And if your a is negative, then that's basically a reflection in your x-axis. Next we look at our k value. This comes right before the x, and that is basically your horizontal stretch factor. I like to think of it as multiplying all your x values by a factor of 1 over k, or in other words, divide all your x values by k. So it's kind of a little bit opposite than your vertical stretch. So in this case, when your k value is between 0 and 1, then you get a horizontal stretch. If your k value is greater than 1, you are going to get a horizontal compression. So now we're going to move on to the h value. The h is your horizontal translation. So you're going to move left or right. And the way I like to think about anything that's inside of a bracket, brackets lie. So basically you're going to be doing the opposite of what you think you should be doing. So if you see x minus 3, you should be moving to the right. And if you see x plus 2, you should be moving to the left. And then finally we have our q value. The q is our vertical translation. And you take the value for what it is. So if you see let's say a plus 2 at the end here, you're going to move your graph up 2. And if you see a negative 2, you're going to move down 2. So basically that just tells you how to move your graph up and down. similar to BEDMAS, when you are going to apply transformations, you do need some sort of order. So the correct order of transformations is SRT. So you want to do your stretches first, then you want to do your reflections, and then later on do your translations. And if you feel very comfortable with it, sometimes you can do stretches and reflections at the same time. So we'll do an example. So we have y equals negative root of 1/2 x and then plus 3. So the first thing we're going to do is we are going to state all of our steps and what we need to do to make this transformation. So the first thing that we're going to do is remember the SRT. We're going to take a look and see if there's any stretches. I do have a K value right here. So I know I'm going to have some sort of horizontal stretch or compression. So the first thing we're going to talk about is our horizontal, and it's going to be a stretch because, as I mentioned before, if your K value is between 0 and 1, then you're going to have a horizontal stretch. So we have a horizontal stretch by a factor of, and remember it's supposed to be 1 over K. So 1 over our K value is really 1 over 1/2. And remember, you can't divide fractions, so we're going to have to flip in times. So 1 times the reciprocal. So basically, we have a horizontal stretch factor of 2. And as I mentioned before, remember, you're going to multiply all these x values by this stretch factor. Again, back to SRT. So the next thing we're going to do is take a look and see if there's any reflections. Well, right here, I see that there is a negative sign. So my A value is negative. That tells me that there's going to be a reflection in the x-axis. So reflect in x-axis. So basically take all your y values and multiply by -1. And then finally, our translations. The only thing left we have here is this plus 3. So the last thing that we're going to do is we are going to move our graph up 3 units. Okay, so if we're going to show all of our steps, the first thing I'm going to do is I'm going to graph the base function. So our base function is the square root function right here. So remember, your Hall of Fame graphs start at 0, 0, 1, 1, square root of 4 is 2, square root of 9 is 3. And then connect all the dots as best as you can, and don't forget your arrows. So the first thing we do is we are going to stretch our graph horizontally. Like I said before, we're going to take all of those x values and we're going to multiply them by 2. So the x value here is 0, and anything times 0 is 0, so it just stays where it is. The next point we're going to look at is this one here. This x value is 1, and we multiply it by 2. So it gets stretched to an x value of 2. This x value at this next point is 4. It gets stretched to an x value of 8. It gets doubled. And this x value of 9 would be all the way at 18. So this first step with our horizontal stretch would look something like that. And remember, you should be labeling your graphs all the way through. So I'm just going to go back and label this blue one and call it square root of x. Okay. Our next step is to do any reflections. So basically, I'm going to take this black graph that I just drew and I'm going to multiply all of my y values by -1, or reflect in the x-axis. So again, 0, 0 stays where it is. This value here has a y value of 1. It's now going to have a y value of -1. This one here has a y value of 2. It'll go down to -2. And there is our reflection in the x-axis. So this would be y equals the negative of square root of 1/2 x. And then finally I'm going to take this red graph and we'll do the last step and translate up 3 units. So basically take every point that you've got there and translate them up 3 units. 1, 2, 3. 1, 2, 3. And the green graph would be our final graph. Y equals negative root of 1/2 x and then plus 3. We also need to talk about domain and range. We'll talk about domain and range of our final graph, the green graph. So remember that domain is the possible x values. So the possible x values of our green graph, well, we know there's nothing to the left of when x equals 0. So x has to start at 0, and then because the square root graph goes on and on forever to positive infinity, then we'd have to reflect that in our domain. So domain for the green graph is the set of all x such that x is greater than or equal to 0. So it doesn't have a right boundary, it just has a left boundary. So greater than 0. And then if we take a look at our graph again, we see that our green graph is no higher than positive 3. So it has an upper bound, but it doesn't have a lower bound. So for our range, we can say the set of all y such that y is less than or equal to positive 3. And that's it for that question. We'll do one more example, an absolute value example. Same thing as last time. We'll start with our base graph, which is the absolute value graph. Now remember, with the absolute value graph, whatever you put in is going to be the positive value. So if I sub in positive 1, I'm going to get a y value of 1. If I sub in negative 1, I will still get positive 1. And that's how we end up getting that nice V shape. So y equals absolute value of x. Okay, so again, remember the SRT. The first thing we need to do is we need to talk about any stretches. So we do have an A value here, and that ends up being a vertical stretch by a factor of 3. I remember your vertical stretches or compressions are your y values. So we're going to multiply our y value. So we can do that now. Remember, this one is at 0, 0, so that's not going to get moved anywhere. But this y value here is 1, and it's going to get multiplied by 3. So we'll have points here, and same on this side. This y value of 2 is going to be 6 now, and same on both sides. And this y value of 3 ends up being at 9, and so on and so forth. So we just connect the dots. And maybe change the color of the lines. And don't forget to label. So this would be y equals 3 times the absolute value of x. Okay, so next we need to look for any kind of reflections, but there's no negative a value and there's no negative k value, so there will be no reflections. And then finally, we need to take a look at any translations. So we have a +2, which is inside the bracket, so that's going to be our horizontal translation. And remember, horizontal translations are always the opposite sign. So I know that I'm going to move my graph left 2 units, and at the same time I'm going to move my graph down 5 units. So I'll take the blue graph that we just created, and I'm physically going to move each point left 2 and then down 1, 2, 3, 4, 5. And take this point left 2 and down 1, 2, 3, 4, 5. And then we just connect the dots and change the color. And don't forget to label. And then we'll talk about domain and range. Remember, domain, again, is the possible x values. Because the arrows indicate that we can go on and on forever, both left and right, we say that x is an element of the real numbers. Our range, however, is no lower than -5. So our graph is above -5, so we say that y is greater than or equal to -5. And that's it for today's lesson. I hope you enjoyed it, and I will see you in class tomorrow. Take care.